All right, hello algebra or G. Wow, hello pre-calc. It's just me today, which is totally all right. That means you guys will be watching the recording. Sorry, it's about this time of the day. There gets to be a a bad glare there. I gotta get like a curtain or something. Um, anyways, what we're gonna do. So let me just talk through a few things real quick. Gonna start with Schoology. We'll get to that in a bit. Okay, pre-calc, perfect. All right, I just want to make a quick announcement. Again, I did start renumbering. So quarter two, week one, instead of keeping the weeks going, I renumbered them. So last week was week one, this week is week two. And again, that's reflected on the pacing guide. So again, you don't have to scroll down as far. I deleted the old stuff. So week one, this was last week, it's right here. Week two, right here. So that's just something to be aware of. Also, IXL, last week I asked you to complete the IXL diagnostic. I know it's sometimes glitchy, or I know it sometimes like wasn't as smooth as it should have been. But I would really like you to complete those. So again, those of you that have, awesome. These 5 students have not yet started. So again, if you need to do it in multiple sittings, if you need to take a break, please do that. But I would like you to attempt to work through that. This whole kind of unit that we're starting, if we just look again, we're starting unit 4 here. We're going to be talking a lot about the unit circle. Okay. So the unit circle is broken up into radians and degrees. So what in the world do those mean? So radians and degrees are just different forms of measurement, different ways to measure in a circle. And we use them both. Now, what you'll find is like radians might be a little bit more new, but as you move forward into calculus and other things, radians kind of become a little bit more useful, or a little bit easier to use. You'll see why. But we've definitely used degrees in geometry and other things. So again, a unit circle kind of breaks up your circle. That's not right in the middle. Not the best circle either. But how it kind of works is if we're going to pretend that one unit, this circle has a radius of 1. So this would mean that my x value is 1, my y value is 0. This would mean my x is 0, my y is 1. This would be my x is -1, my y is 0. And this would be my x is 0, my y is -1. So again, remember quadrant 1, 2, 3, and 4. And so if you can memorize one quadrant, or if you can figure out one quadrant, you can figure out all the rest of them by looking at their positives and their negatives. So again, certain quadrants are going to have X values that are positive. Certain quadrants are going to have X values that are negative. And that's going to hold true throughout the whole thing. So again, maybe I'll split it up. The easiest one to start with is at 45 degrees. So again, this is like a 45-degree angle. And what we're going to do is we're going to call this square root 2 over 2, square root 2 over 2. We can get into it. Again, it's basically if we create a triangle here. So if we were to do that, again, what I would have is I'd have my radius would be 1 because we set our radius as 1. And then because it's a 45, 45, 90 triangle, we know that we have a shortcut, which again, normally we would say that this is x, this is x, this is x square root 2. If we know that this is 1, so 1 equals x square root 2, we got to divide it. We got to divide it. We can't leave that on the bottom, so we got to multiply it, and we get square root 2 over 2 equals x. So that's how we got these coordinates right here. And again, this is at 45. So your degree measure is 45 degrees. Your radian measure is going to be pi over 4. So this is going to carry out throughout the whole thing. Again, instead of pi over 4, it's going to be 2 pi over 4, which is really pi over 2. And then this is not just 45 degrees, it's 135 degrees. And my coordinates, again, following my rule, x is negative, y is positive. So I have negative square root 2 over 2, and y is positive square root 2 over 2. And so again, that keeps going. This would be 3 pi over 4. Let me double check something. Oh, so I kind of goofed up. So again, this is right here as we keep going. This would be pi over 2. This would be, so again, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and the whole thing is 8 pi over 4 or 2 pi. And so we know that, again, all the way around the circle is 2 pi. We know that. And then we're going to split it up. So again, I like to just focus on one quadrant. So we've got our 30 degrees, we've got our 60 degrees, and then we've got our 90 degrees. So again, as we kind of think about it, okay, if I'm in radians, if I'm in degrees, we're used to doing degrees. If I'm in radians, this is like pi over 6. 2 pi over 6, which is really pi over 3. Then I go 3 pi over 6. Hey, 3 pi over 6 is really pi over 2, which we already calculated. So again, 30 degrees, 45 degrees, 60 degrees, 90 degrees, plus 30. This could be 120 degrees. So again, pi over 6, 2 pi over 6, 3 pi over 6. This would be 4 pi over 6 or 2/3 pi. 5 pi over 6, 6 pi, which again, 6 pi over 6 is really just pi, which is the same as we already figured that out. Then we've got 7 pi over 6, 8 pi over 6, which again is 3 pi over 2, 9 pi over 6, which we already said was 3 pi over 2, 10 pi over 6, which we can simplify to 5 pi over 3, 11 pi over 6, and then 12 pi over 6 gets us back to our 2 pi. So understanding one quadrant, okay, one quadrant of your unit circle can help you throughout the rest of it. Now let's talk about the coordinates real quick. So again, as I look at this guy right here, I'm going to draw it out. We said that we had a triangle and it was 30 degrees. Well, good thing a triangle is one of our special triangles. We said the radius was 1, and so if that's 30 and that's 90, this has to be 60. So we have special rules with our 30, 60, 90 triangles. This is going to be half. This is going to be half times the square root of 3. So it's going to be square root of 3 over 2, and then my radius is 1. So as I look at my coordinates, again, my x value is longer than my y value. So this would be square root 3 over 2, 1/2. And then I would flip them and say up here at 60, this would be 1/2 square root 3 over 2. And you could keep doing that again, adjusting your positives and negatives no matter where you are. So radians and units, again, figuring out which one is which. I do strongly recommend that you either keep on file or you print one out. Go ahead. You're going to have to fill it out yourself. If you make it nice and neat, you can use it. If not, just have one of these guys handy. Okay. So again, this is something that you can come back and reference to. This is just a unit circle. Again, it's very neat, very organized, and you've got everything that you need to view or to see right here. Kind of a quick introduction into radians and degrees right there. we also kind of looked at finding arc length. So, and this is where when I touched on earlier about finding, you know, finding reasons to use radians, this is one of those reasons why that radians can actually be um, more useful. Because if we're trying to find an arc length and we have the problem in radians, all we have to do is take our radius times whatever theta is, which again, if it's in radians, it's easy. However, if it's in degrees, so again, this is radians. If it's in degrees, we got to do a little bit extra steps. So we still take theta times our radius, but we have to take pi divided by 180. Okay. Now, again, this is kind of derived from our unit circle where we have 360 degrees for our unit circle, but we only have 2 pi radians to get all the way around. So 360 takes us all the way around. 2 pi also takes us all the way around. So we kind of got to look at that. I guess we can do one example here real quick. So if I had a circle, something like this, say this is 10 centimeters and this is 40 degrees. Again, because I need degrees, I'm going to use this one. So my theta is 40, my radius is 10, and I'm going to multiply it by pi over 180. I would recommend keeping it in terms of pi. So just doing 40 times 10 is 400 divided by 180. And I can kind of simplify that into as 2 and 2/9 pi, or you could say 20 over 9 pi. Again, kind of this very similar, but you want to simplify that down. I'd probably use this. So what's my arc length? My arc length is 20 over 9 pi. And again, I got that by simplifying. I know they got a 10 involved, so I can divide by 10, divide by 10, 40 over 18, divide by 2, 20 over 9. All right, again, I'm one other thing, or two more things, I guess. We can have something called a coterminal angle. Basically, it means the same thing. So I could have something like this, or I could spin. So let's call this angle 60 degrees. I could spin all the way around, go past 360, and get to this angle again. So again, I would say 360 plus 60. These coterminal angles, one of them could be 420. So a 60-degree angle and a 420-degree angle are actually the exact same angle. I just went past 360. Again, we're used to opening up our angles this way. So again, if we go this way, it's sort of positive. Think about our quadrants, 1, 2, 3, 4. Or if we go the opposite way, say we open it up this way, we would call this a negative. So again, if I were to say this right here is positive 270, a coterminal angle could be negative 90. So I could go positive 270 or I could go negative 90 degrees and actually end up in the exact same spot. All right, well, let's just look at a few examples, a couple practice problems. Again, you guys will be watching the recording, so you'll be able to try these. I might do one or two of them. Let me find it. I believe it's this one. Yep. And I want to preview. Boom. So again, to kind of work on this one, I would add 360. I would add 360 to this one. I don't really like, this isn't quite what I want. Here, let's just look at this, okay? Make it a little bit bigger. All right, convert from degrees to radians. Again, we talked about how to do that, multiplying by pi over 180. If you had to go the other way around, you would flip-flop 180 and pi. How do you feel about converting? Okay. Very similar type of problem. This is what I was mentioning earlier. Radians to degrees, you got to invert 180 and pi. So notice the difference between question 3 and question 4. You're going degrees to radians. And then question 4, you're going radians to degrees. Very important to keep those two things straight. Talked about the quadrants. Again, a negative 570. So that means it's going to go all the way around once. 360 plus 180. Well, 360 plus 200. So I know it's over that half point line is only negative 3 or 560. So I'd have to go a little bit more. So that would give me quadrant 2. Negative angles are measured clockwise. Again, what quadrant? Remember, it goes counterclockwise 1, 2, 3, 4. Coterminal angle, we already talked about that one. Some negative and positives. Again, if I wanted a positive, I'd add 360. If I wanted a negative, I'd subtract 360. This is another example of just, again, 50 degrees, or if I go all the way around to the left, so that's negative 360 plus negative 50, that's going to give me negative 410. Which of the following shown graphs 11 pi over 6? So again, as I'm thinking, okay, this is pi over 2. This is pi. This is 3 pi over 2. This would be 2 pi. It's got to be this one because 11 pi over 6 is in between 3 pi over 2 and 2 pi. It's the only one that would work. We get it right? Yes, we did. Oh, I guess we didn't, because this would be a negative angle. This would be negative because it went left. We need it. So they're the same angle. They're coterminal, but we need to make sure that we're going the standard position. So Mr. Larson almost made a silly mistake there. Find the arc length. Again, this is what we kind of talked about. All right. I'm given my radians. So all I have to do if I'm given my radians is to multiply it by my radius. So when we have radians, it is easier than when we have degrees. And you'll notice if we think back to how do we convert things, really our formula for finding arc length is we convert the degrees to radians and then we multiply by the radius. That's all we're doing. So I would say 3 times 13 gives me 39 pi over 4. Boom. Simple as that. Okay. So what I'm asking for you to do again after you've watched this recording, well, first off, again, notice we're kind of taking our time, really spending a lot of time on this. Next week is a short week. We have fall break. I'm going to release this now. So again, you only have one assignment. I'd like you, if you are done with your diagnostic, to work on your diagnostic. If you're not done with your diagnostic, practice some of the skills that it recommends. If you're not done, I need you to finish that. So I've uploaded next week. Again, only 2 days of school. Make sure we get that done. Your Class Connect assignment is a couple problems, I believe. And I'm not going to tell the answer to you. Again, we've talked through them. We actually did this one earlier. So again, if you want to go back and find that one, we did that one. Convert from radians to degrees. Again, there's a formula that we can follow to do this, convert from radians to degrees. You could also potentially find, hey, where is 3 pi? Oh, geez. Where is 3 pi over 4 on my unit circle? Okay, so again, if I say, well, if I were to find 3 pi over 4 on my unit circle, I think I could determine what that was. And last but not least, using the unit circles, what are the x and y coordinates of 5 pi over 6? So again, I'm really trying to hammer the point home that we need to know our unit circle. And if you look at what your assignment is, I believe it is this one. Your assignment is literally to do the unit circle, okay? Fill out the unit circle. Make sure radians go here, degrees go here, and then your units go here. I tried to highlight it to make it easier. If you want to just draw it on your own, if you don't like this highlighted one, maybe I'll add the blank one in as well. But that's what I've got for you. We do not have a Class Connect next week with only 2 days of school. So have a great fall break. Stay warm in this cold weather, and I will see you in 2 weeks.